Hey everybody, this is Mr. McKee with NET 226. Today I'm going to be going over Packet Tracer 6.2.7, which is Investigate NAT Operation. All right, let's look at our topology first. I'm going to zoom out a little bit. All right, so we got three different domains here, or areas, whatever you want to call them. All right, we have home office up top with a wireless router hooked to a modem out there to the internet. Couple wired end devices, couple wireless end devices. All right, we have central domain, which has one router, two layer 3 switches, kind of like a distribution layer right there. Then you have your access layer switches lower down, and then you have two PCs hooked to each of those LANs. All right, then you have a central server over here on a separate LAN. All right, and we have a two WAN connections, one out to the internet, and then back over to the branch domain, and you have a intranet, which is like an internal, for lack of a better term, an internal intranet. But you have that going over there. All right, then you go to router 4 in the branch network, and that has one switch, couple IP phones, and then PCs, wireless AP, two wireless devices, and a branch server and a laser printer. All right, so let's go through this thing. All right, looking at our addressing table, we have router 2 has 5 interfaces, 2 gigabits, and 2 serial connections, which are out here in red. All right, router 4 has 3 interfaces, and our intranet is the interfaces with the .1, let's see, 001. They have .1 on here, but S001.1. All right, and then our wireless router has a LAN interface, which is on the internal side, and then an outside interface. Let's see if we can mouse over it. 00. So that's the internet side. All right, so the scenario is, as a frame travels across a network, the MAC addresses may change. IP addresses can also change when a packet is forwarded by a device configured with NAT. In this activity, we will investigate what happens to IP addresses during the NAT process. All right, so part 1 is investigate NAT operation across the intranet, which is the bottom WAN. All right, so wait for the network to converge. It may take a few minutes for everything in the network to converge. You may speed up the process by clicking fast forward time. I don't need to do that. Everything looks like it's converged, but I'll do fast forward anyways. All right. Now this sometimes gets a little tricky because we're going to be using simulation mode. All right, so step 2 is generate an HTTP request from any PC in the central domain. So generate from here, the central domain, open a web browser on any PC. Let's switch to simulation mode first, bottom right. All right, has our simulation panel open. So open it and edit filters to show only HTTP requests. So let's hit edit filters. More than likely only HTTP is selected anyways. All right, yep, HTTP is already checked. All right, so we're good there. Okay, sorry, my phone rang. All right, so we edited filters to HTTP only. All right, all that looks good. Let's go up here. Open the web browser of any PC on the central domain. All right, so I'm gonna do PC1. All right, web browser is over here on the right. All right. So let's type HTTP. Whoops, got caps lock on branch. PKA, click go. Minimize the browser window. Click capture forward into the PDU or protocol data unit is over D1 or D2. All right, here it comes. All right, so it's at S1 and then it's at D1. All right. Click on the most recent PDU in the event list, which is up here. Record the source and destination IP address. All right. Well, I didn't want to do that. Really? There we go. All right. Daggone, it doesn't like me dragging it over that way. All right. Source and destination addresses. All right, source and destination right here. Source 10204, destination 64.100.201. All right, and so 10.2. So router 2.10. Look at some more stuff in here. 10.204. That's weird because it should be getting this interface. So 1. All right, so to find out this, get back here. Where was that? All right, so source IP, and this always acts crazy when I try to resize it. All right, let me move that down there. All right, so my source is 10.204. So PC1. All right. All right, 10.204. Okay, that's there. You notice that's assigned with DHCP. All right, and then our destination IP address is 64.100.201. All right. 64.100.201. So that's router 4. 201, which should be this interface right here. 201. All right. So we clicked capture until the PDU was over D1 or D2. Click on the most recent PDU in the event list. Did that. Record the source and destination IP addresses. Got those. To what devices do those addresses belong? And I'll let you guys know, I believe there's like 14 questions in here, but I've created a Word document. I'll put in the submission link of Moodle. All right. So click capture forward until the PDU is over R2. So let's keep going fast forward. All right, PDUs are R2. Record the source and destination addresses in the outbound packet. All right. So outbound PDU details. Let me see what this says. In layer, out layer. Let's see, dot 3 must be that layer 3 switch. Okay, Alright, so source is 64.100.103, destination 64.100.201. Alright. So to what devices do these interfaces belong? Well, we know what 64.100.201 goes to. 64.100.201 goes to that interface. But now to find the 64.100.103, we've got to figure out where that goes. Okay, so we know 64.100.201 is R4 S001.1 interface. All right, so find where the dot 3 is. Let's see, 64.100.100, 64.100.100 R2. To figure out who owns that, I'm thinking probably, let's click on R2. If you guys are looking for the, so it has the username administrator, password Cisco, enable class is password is Cisco. Alright, enable password is class. Alright, let's do show run. And more than likely 600, 100, 64, 100. Let's look for this thing. NAT poll 64, 100, 103. All right, so let's look through this thing. So we know that the dot 3 is part of this R2 pool. All right, 64, 100, 100.3 through 64, 100, 131 with a net mask of that. All right, so let's look. All right, so we can tell by this, let's see. 100, 100 to S000. Look at this interface. Actually, let's do this. Show interface. Show interface, I believe. Oh, show IP interface. Yep. All right, not there. Let's do Cisco enable class, show IP interfaces, not on that one. Let's do R4. Really? All right, so so we know our destination is going to be S4, but now our source address is actually an address assigned by R2. All right, and I'll show you guys that again. That's kind of confusing. I had to look at it a couple times myself. All right, it's being assigned by R2, which it's the very first IP address of the DHCP pool, R2 pool. All right, so it's going from there, and then the destination is 64.100.201, which is S001.1, so it should go this way. It should go over the intranet, all right, and then to that interface. And if I make this a little bit smaller, see this at serial 001.1, all right. So basically the first interface isn't assigned to any interfaces on the network. The second one is R2's serial 001 interface. Serial 001.1. It's kind of confusing how they did that. All right. And let's continue. Close that down. All right. I guess I should always just read to the next question because I like to figure out the answers myself, but then if you go to the next question, log on to R2 from the CLI using the password class, which I did, enter the privileged exec mode, and issue the following command. Show run pipe include pull. Okay, so there's the first. That's the same information I had from up here, which is right here. An IP NAT inside source list 1 pull, R2 pull. Okay. So the address came from the NAT pull, R2 pull. So did I say DHCP pull? IP NAT pull. All right. So click capture forward until the PDU is over R4. All right, so there it goes over the intranet, over to R4 in the branch domain. All right, click on that one. All right, record the source and destination IP address of the outbound packet. And I believe this is the same, 103.03. Let's see, 103.03. Yeah, you can look at the inbound and outbound packets, and then you can look at both of them together. Record the source and destination IP address of the outbound packet, which is right there. To what devices do these addresses belong? 64.100.103 was what we had last time on R2, and then 172.16.03 should belong to R4. And before I go looking for it myself, let's see what they got. Click on both R2. Well, let's look at R4. I just want to see what it looks like. Oh, did I click that? Oh, that's just great. Did I lock it up? Looks like I locked it up. Oh, there, no. in simulation mode, it probably won't go away until I do this. Nope, still doing it. Now let's try it. There it goes. All right, so now let me back up. All right, we are right there. All right. Let's click on R4. Do enable class. All right, and I want to do the show run include poll. All right, so there's no poll on that side. Let's just do a show run then. All right, so it's a 172.16.03. It's an excluded address from the DHCP on this side, so more than likely it's an interface or a server. 16.03. 01 is the interface, going that way. So I'm thinking it is, the simulation thing's always hard to manipulate. All right. 172.16.03. There it is. All right, so it's going to the server. All right, so that should answer that question. Let's see. So that answers that. What are these devices? To what devices do these addresses belong? All right. Click capture forward into the PDU is over branch server PKA. All right, then it goes up there. And you see how I clicked forward to get rid of that error ahead. We're actually right there. I just went ahead when it was sending a reply back. All right. Record the source and destination TCP port addresses in the outbound segment. So TCP port. And it says outbound, right? Our TCP port is 80. Destination port is 1030. All right. On R2 and R4, run the following command to and match the IP addresses and ports recorded above to the correct line of output. Run the following command and match the IP addresses and ports recorded above to the correct line of output. There's R2. Let's do R4. Okay. There's both of those. What do the inside local IP addresses have in common? Inside local. Right, what do all those have in common? You should be able to name that. There's your well, I can't really click on it. There's your outside address, other outside addresses. All right. It has to do with being able to go outside that local area network. All right. And do any private IP addresses cross the intranet? And if you compare this to this, you should be able to tell. If you look at this, outside local on this side, outside local on this side, those are on the same. well, they're not on the same network, but they're on the same, both routable. All right, and then on the other side, on the branch network, all these are inside addresses also. All right, a little bit confusing, but that's all right. All right, so let's see. What do they have in common? Do any private addresses cross the intranet? No. Click the reset simulation button. All right, so let's close all this down. Reset simulation button is right here. All right, it started back over. And I know it's going to be hard to see, but let me shrink it down a little bit. All right. Investigate NAT across the internet. Generate an IP HTTP request from any computer in the home office. And I guess I'm going to use home desktop. All right, so we want to go to central server. Okay, so central server.pka. All right, got that. Click capture forward until the PDU is over WRS. All right, so there it goes. All right, now it's over WRS. All right, inbound. Record the inbound source, destination IP addresses, then the outbound source and destination addresses. To what devices do these addresses belong? All right. It may be easier just to look at that. All right, source 192.168.0.101. All right, so that first one belongs to WRS. See, this thing goes crazy. Let me shut that down, open it back up. Really? All right. And the second one, 64.100.102. Oh my gosh, this thing drives crazy. Let's see. So 64.100.102 is on, that's the serial 000 interface of R2. Come on. Golly. All right, I want to do this. I want to do this. I've never got good at doing this. All right, there we go. Don't. Yep. All right, so whenever that's going, 64.104.223.2 on the outbound. 64.104.223.2. That's going to outbound to the internet. So that'll be like our LAN, or not our LAN, our ISP. All right, and then destination 64.100.102 is the serial 000 interface on R2. So that's the three places they're going: WRS, router 2, or internet, and then router 2. Okay, so what do we got? So we did that to WRS. To what devices do these addresses belong? Computer R2 and WRS and R2. Capture PD. Capture until the PDF is over R2. All right, there it goes. record the inbound. Is that where? No, I'm here. All right, so source and destination. Source and destination of the outbound. All right, 223.2 is the internet. 64.104.223.2 and destination 10.10.10.2 is going to be a, well, here I'll show you. If I can mouse over it. So 10.10.10.2 is central server. All right. And this thing, I swear. All right. What else do we have here? We did that. On R2, show the running command and match the IP addresses and ports recorded above to the correct line of input. And did I just reset this thing? Hang on once. Okay, sorry, I had to pause this thing for a little bit. Sometimes if you close down the wrong thing or click on the wrong thing, this simulation run kind of like has an issue, and you just have to go to real time and just power cycle your devices. That's what I just did real quick. And once you do that, you go back, and will it let me do it? Probably not. Here, I'll show you what you would do. All right, won't let me do anything in simulation mode. All right, for whatever reason. All right, go back here, go back to real time, power cycle devices. All right, everything will turn red to fast forward time. Some stuff will take a little bit longer to converge. All right, that I'm really not worried about since that's on my path, but let me go back to simulation, go back here, go back to edit filters. HTTP is the only thing by default. All right, let me go to home desktop again. And I'm going to do HTTP central server dot pka. Click go, close that down. Now you can do fast forward. Maybe it'll work. Come on. See, it still doesn't work. All right, let me try it again. Try to power cycle it here in simulation mode. All right, so everything's down. All right, click on that. Actually, it's not quite there yet. All right, there it goes. All right, now it looks good. Let me go back to simulation, go there. All right, everything should be good. I don't think, let me reset the simulation too. All right. This is really good to show you how the packets and how the frames and everything are moving around the network, but sometimes it's kind of hard to get working. Okay. All right, now we got that. Now let's do fast forward. Come on, packets. I need my packets. Control copy, control paste. All right. All right, user should be working. All right, now let's do Reset it one more time. All right, now I understand why it's not working. See this thing? When you reset it, see how my default gateway has not been picked up yet? That's not going to work. It's weird why it's like that. All right, for whatever reason it was set to static, but now it's working. All right, now let me go to simulation. See, weird stuff happens. All right, central server.pka. I think sometimes when you hit fast forward time, it doesn't converge correctly. All right, so now it definitely should be working. Maybe. Fingers crossed. All right, so I had to troubleshoot this thing for a couple minutes. For some reason, my home desktop is not working now, but now my home laptop is working, sending packets. So let's watch what happens. All right, so there it goes. All right, so it's at R2 now. Let's see, capture, record the source and destination. We did that. On R2, run the following command and match the IP addresses and ports recorded to the correct line of output. All right, so let's go here, enable class. All right, show IP NAT translations. Okay, so what we're looking at, let me see what we had. So that is 64.100.102 is the serial 000 interface on R2. Okay. And then 10.10.10.2 is 10.10.10.2. Is this inside IP address right there? Nope. 10.10.10.2. 10.10.10. Oh, gigabit 002. I'm sorry, it's on this side. That's the server. All right. I know this is like kind of confusing, but it's weird out why it's working now. Now it stopped working. Let's see if I can do it again. I bet you it won't work. Fast forward. Yep, it has issues. All right. So return to real-time mode. Thank goodness we're out of simulation mode. All right. Did all the web pages appear in the browsers? Yes. Appeared in that one. All right, so experiment with more packets, both HTTP and HTTPS, and answer the following questions. Did the NAT translation tables grow? All right, you guys can work on that. Take a look at that. Let's see. Does WRS have a NAT pool of addresses? You guys could answer that. Is this how the computers in the classroom connect to the internet? you could say more or less. I mean, the computers, yes, they use the same external IP address. More than likely, like here we have a block of static IP addresses on a /29 subnet given from our ISP, and then the inside there's a NAT translation that uses that one IP address that's outside. It translates NAT from all the internal IP addresses, and what it does, it gives new ports to all the connections going out. And then if anybody outside sees that external interface IP address on the internet, that's how that works. All right, let's see. Why does NAT use 4 columns of addresses and ports? And to see why NAT uses 4 columns of addresses and ports, here's your inside global. All right, inside local. So there's your translations, and then you have outside local. Then outside global. And you notice these right here are the same, but that's how that works. All right, let's see. Where are the networks? Where are the networks or outs? Inside global and inside local. What? That doesn't make any sense. I guess it's saying, why are the networks? Where are the networks? Maybe it means, where are the networks that are inside global and inside local? Maybe? So inside global is like this one right here, 10.2 or 100.2. All right, that's the interface that they use to all the inside addresses used to get out to the internet. All right, this will actually get bigger. This NAT translation will get bigger if you use different computers. Like we only connected with the central server. If you connected to a lot of different computers, that would grow. This would always be your inside global address. You can see what ports they went to. Port 25, secure 443, and just a standard HTTP port 80. And let's see. Inside local is the actual inside address that is static for the router, for this server, and then if you have DHCP, that would be the DHCP routable inside. Now let's see, on which devices are NAT services operating? What do they have in common? Well, NAT services here, NAT services here. All right, show NAT translations. And the big similarity is they're able to route traffic. So you can say they're, because they're routers. And then also this routes. Of course, I can't show you the config. It won't let me click on it, but that's the big similarity. They route the inside interface, the inside IP addresses, and they change those to a routable IP address out to the internet. The only way you can tell between all the different computers that are inside is they're assigned a usually a 4-digit port number. All right, And that's it. I know that took a long time, but using that simulator, sometimes that's hard to do. But I think you had 14 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Maybe it's 13. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, 13 questions to answer. And I'll have those in a Word document on Moodle. All right. And I know right now I'm making this video, the school's closed down because of the virus going around, but hopefully you guys, if you guys have a chance, take a look at this video, and then also I'll change the due dates for everything. All right, that's it. Thanks for watching.